Topic B, built-in modules. Now you've seen how easy it is to create a Python module, and you have already experienced importing modules that are already existing in Python. For example, we imported math and then used math.py to get that exact number for pi when we did some geometric calculations. So you can probably guess that Python has actually hundreds of built-in modules. So we're going to take a little snapshot and talk about some of them. And here's a list. Now, some of these we have already used, some of these we're going to use in this very lesson, but these are some noteworthy ones that you should know about. So string. So this one has functions and attributes for working with strings. We're actually going to use string.punctuation in a tutorial coming up. Then math. Math is the one we imported, math.py. So it has great many more mathematical functions. Unit test helps with error handling and doing that in a more systematic way. Sys is an interesting one. You might have seen like import sys and sys.exit, which gets you out of Python. Well, sys interacts with a Python interpreter at the level of bits and bytes. It's actually, out of these, probably the most advanced. OS. This is a fun one, so that interacts with your operating system, so you can basically use OS to shut down and restart your computer, for example. URL lib is basically designed for working with URLs and sending HTTP requests, for example. Time. Time is one that I'm going to be using. Actually, I probably used it in a previous tutorial to time how long it takes to generate a list of prime numbers. So there's a great many different time functions. We're going to use another one in examples coming up. Random. So I don't think we've generated random numbers yet. I might have put that on an example, but random, yeah, random generates random numbers, and it's a bit more advanced than that. You can use different random distributions, not just a plain, purely distributed one. RE works with regex, regular expressions. We haven't covered them in this course, but they're fairly used. They're a relatively advanced concept though. Itertools works with iterating through various iterables, and functools works with functions. So let's go ahead and just have a little bit of a play with importing some modules and looking through the module documentation in order to use some of the methods that are in the modules. So in this video, we're going to get a little bit of an insight into what you've seen there as a table of variety of built-in Python modules. We're going to look at two that are on the simple side. One is famous for basically, being used to teach kids programming, and the other one is time. Time can be useful in programs in multiple ways. So we're basically going to import the two modules of turtle and time. Then we're going to look at the help for both of those. So that'll be a little bit of an insight into the modules and the functions inside them, as well as doc strings. Then we're going to use turtle to draw a shape, and time to have that shape sort of linger and hang around on the screen. So let's get started. We can import turtle, time. Now, for the time being, especially in tutorials, I actually prefer not to use that star thing, because you guys are going to know when I'm using these methods where they come from, which module. Whereas if I imported both of them with a star, you wouldn't know what's turtle, what's time, although generally you'd be able to guess. Okay, so let's look at some help files. So we can print help turtle and see what this is all about. You can see a lot of stuff printed. Turtle originally developed in 66, and really explains what the Python module has, shows you all the classes and methods defined here. And you can see the real insight into object-oriented programming, because practically all of the parameters are built in. See shape is preset to classic, buffer size preset to 1000, visible preset to true. So it initializes itself. We've got these methods, begin, fill, hold just before drawing a shape, so it's got filling shapes, begin poly. So all I'm looking for is some simple ones that are going to drag lines. So we can leave stamps, clear stamp, clear, and this seems to be alphabetical rather than any other. You can see that you all would see clone itself, return a clone of the turtle, so make another turtle object dot end fill, end poly, filling, get poly, get shape. So you can actually search here, and what I'm looking for is forward. And you can look, there you go, example, turtle forward. So move the turtle forward by the specified distance. So I'm just going to draw a shape, and this is kind of going to blink into existence on my screen. So I'm not sure that you're going to see it, but I'm just going to say turtle.forward and number of pixels. I'll say 100. And when I play this, there's a screen that appears. I actually have 3 screens, but the screen that just appears and goes away. Now, I have a cunning plan, and that involves searching for the speed of the turtle. So one way is, not only can we make the shape linger with a little bit of time, but we can actually slow the turtle down. So if I'm here, I can control F and search for speed. So there is a speed method, number range 0 to 10. Return or set the turtle's speed. Now, I wonder if we said turtle.speed 1 and push play. It's still a bit slow, but if we say here 500, I'm sure we'll be able to capture the magic of turtle in time, and then that's going to disappear. So that is the turtle screen. So what I would like to do is draw a shape that's going to require some turning, and then have a way to have that shape remain on the screen for a certain number of seconds by using time. So we're also going to look inside this turtle documentation for turning, because we want to turn that turtle so we can draw a square. So in here, control F, turn. So there's going to be a lot of return, especially the turning of the turtle, and that's the problem with the word turn. What about right or left? Turtle.right 25 seems to be a command, so there's got to be a function that's basically .right. So right. Turtle.right, self-terminate by an algorithm. So we can basically say turtle.right, and that can be 90. So forward can be 200, and we repeat that 4 times, and we have our shape. Forward 4i range 0,4. And our little experiment is going to produce a square. And there is the square, and it's going to disappear as soon as it comes into view. At this point, we're going to look at the time. So I'm going to go into help instead of turtle. I'm going to say time, and we're going to have a look. So I'm going to look for wait for sleep. So there is a dot sleep, and it delay execution for given number of seconds. Okay, so time dot sleep, and we can make that 10 seconds. So I'm going to bring in this shape, and it's going to remain on the screen for 10 seconds, thanks to a combination of turtle and time. Everything I needed to learn to create this is actually given and provided inside the turtle's help, inside Python's help function, and which it essentially looks at classes and methods and the documentation written together with them. So I hope that if anything, that this little exercise emphasizes how well the popular Python libraries are documented, and how, without even having access to books and online tutorials, you can glean a lot of knowledge just by looking at the help function of these popular Python modules. So here's another scenario that we can practice with. It goes as follows. You're a programmer working for a logistics company which is looking to implement an algorithm for purchasing fuel, and you have been asked to provide some mock data to basically test this algorithm. So what your job is to write a function that returns a randomly generated list of 30 floating point values, each one between 110 and 145. 1.10 and 1.45. So that's going to be a function. It's going to have a return statement. What's going to be in the return is going to be a list. And the example output looks like this. So this is an example of what you could have for the function. I'm going to call it petrol vowels, and that's what it returns. As you can see, there's some numbers do repeat. See, I think 1.3 happens in 2 places, so it has to be, just double check, it has to be like truly random. It has to at least appear to be truly random upon inspection. So, have fun doing that. Try it first on your own, and then check my upcoming solution. So, here we are. The scenario specifies that we need to write a function that returns a list. And that list has 30 randomly generated, so random sized floating point values, each one being between 110 and 145. So, there's a couple of ways to approach this. We are going to use the random module, and we're going to look up what it has in it, random. So let's start here, help random. So we can just think about this, generate, and know that there's a random integer thing that you can do, so we can randomly generate 30 integers between 110 and 145 and divide those by 100. I think that's one method, but I want to see inside and see, is there some other more shortcut way to do it? So, I don't think this documentation is that big, so let's have a look. Aha, random sample. Wade? No, we don't want Wade. Random permutation? No, I like that. Random sample. Control F. Yeah. Find me the next one of that. Nope, there's only one, it seems. What about random sample? Maybe you've got an underscore. What about sample? Aha! Self-population K chooses K unique random elements from a population sequence or set. So it sounds like all I need to do is produce an iterable, and it'll pick K unique random elements. This is interesting, unique. So, I mean, we're dealing with, let's test this idea. I would be curious if this works. I'm a little bit concerned about unique, but we're going to find out how that one goes. So it's got seed, sample. So if we can generate some data, like sample, maybe make a list if possible, prices, and we can populate it because all the possibilities are from 110 to 145, right? So you can say, hey, price equals to 1.10, and then you can do while price is less equal to 1.45, you can price plus equals to 0.01. So then we can add that price to the possible prices. Possible prices that depend price. And if we print possible prices, then we'll know this is cool. Possible prices. We'll know that's something that we can take the selection from. What's your problem? Invalid syntax. We could probably hide the help. It's getting away with our program. Okay, good. Good. Because it's a float, because it's a floating point, let's see, this is like, you have this kind of rounding error, but I'm sure you can like round it. So if you say round price, comma 2, that should do it to 2 decimal places. Use that method before. Yeah, good. So there you go. You have all of every possible price. And now if we can make a random selection from the possible prices, then that could be what we can return. So since we have to do a function, I might as well just put it all into a function so we can here define it, def, petrol, vowels, and we have possible prices. So we could basically return random dot sample. That was the method. Sample, and yeah, population, so K numbers, that thing came, and now it's gone. Let's bring it again. Go with you, bring the help. The word I'm looking for is Control F. Sample. Okay, from a population, K unique elements. So in here, you were going to put a random sequence or a selection. So we can put possible prices, and we want 30. And now we can print petrol vals. Alright, function petrol. Okay, awesome. So the only thing that I'm worried about is that this thing is going to basically not repeat a single number. And it seems to be making unique elements. And random data in reality isn't like this. You notice there's only one 1.13, only 1.3, only one 1.29. So the sample won't work because of unique elements. There's another random method that I had spotted, and it was random.choice. I believe we can test it, random.choice. And if we say possible prices here, then it'll give us just one, so it'll pick one price. So it'll basically pick a different one every time. So in this whole while, I can create an output, and that's going to be a list, and I can output dot. So 30 times I could append for I in range 0, 30 output dot append random, and we can, so that was output dot append. Then that disappeared, and we can just return output, and that will work, sure. So all we're looking for is a couple of duplicates, C1.44 and 1.44. Yeah, that's truly random data. So that actually, the sample tripped me up, and that didn't work as easy. So I'm going to do another method, and I'm going to call it petrol vals 2, which I'm going to try to make as easy as possible. So if I'll just kind of copy the header, save some time. I'm going to call this petrol vals 2. I'm going to also use the output. In fact, I'll also use this for I range 30. But there must be, here's what I'm going to try to do an easier way. So instead of appending that, I'm going to do random.roundInt. So that generates a random integer. I'm going to go a number 110 to a number 145. Then I got that. I'm going to divide that by 100. And what you're going to have might be the same rounding problem as before. But let's just test this out after we return the output. And if it works, we can just round. So petrol vals 2. No, that's beautiful. That is beautiful. And see, the list is different every single time. So that is a much shorter, much simpler function. But there you go. We had our exploration of the random built-in module, and we came up with two completely different ways to solve the same problem. So in summary, both these functions perform the job of coming up with 30 randomly generated floating point values between 110 and 145. I've rounded it to 2 digits since we're talking about petrol prices, and that's basically how petrol is priced.